Now let's take a look at this figure 14-11, and it deals with the operating torque. That torque is produced by the way the rotor and the bars in the rotor are designed and cut into the rotor. And of course, that's how you design B, C, or D motor is produced by arrangements of your bars in your rotor. And notice if you're down deep, that's going to be design D. And as you get closer to the surface with your rotors, the less torque is produced, and that's where your design comes in. For example, the oil companies out there, we have those rocking horses. They'll use C and D motors. A lot of times they're D motors. Up on the slope of Alaska, they use a D motor to pump oil. But just regular, normal use, that Class B motor is just about, I'd say 95% of all your motors is a Class B motor, because you can back the overloads up with fuses and have double protection on motors that are hard to get, to order and so forth. Yeah, waiting time maybe is a little longer, and they have no means to wound those motors and wind them and that kind of thing. So what this figure 14-11 is showing is how the operating torque of a motor is produced based upon the bar and how deep it is set into the rotor to pick up this magnetic field flux and produce more torque to accelerate and drive the driven load. We get requests, how do you determine the load that the motor's driving? Well, if you're any of you interested in that, just get a copy of Stallcup's Generator, Transformer, Motor, and Compressor book, and we show you the formulas in there how to figure that. And they're formulas that electricians use. Engineers can go into it a lot deeper if they want to, but they usually come up with a similar calculation to determine it. So if you want to know that, you can purchase the book and do a lot more study. But if not, if you're just interested in how these motors operate and how you size your conductors and your overcurrent device, your overload, your controllers, your disconnect, the basic 7 steps in motor design, that's fine. But here you get the operation so you can tie why you have to do certain things in the NEC. It's because of the operation of the motor and what type of motor is it. And so that's what this figure 14-11 is illustrating to you, is that the deeper these bars are cut into the rotor, then the more torque you're going to have, and that's why you have your B, C, or D listed in table 430.250 and table 430.251 of the NEC.